Hello students, today we are going to study the S block element student. Okay, so S block element, what are the S block element student? The last electron in which, the element in which last electron enters into S orbital is known as S block element student. Whatever the, element having the last electron entering into S orbital, that is S block element. Location in periodic table. S block elements are placed in extreme left side of periodic table in two groups. Okay, group number 1 alkali metal and group number 2 alkaline earth metal, right? So let us have the look of the group 1 student. Group 1 elements are also known as alkali metals as their hydroxide are extremely alkaline or basic in nature. Okay, so why you are saying that is they are the known as alkali metal student? Because their hydroxide are extremely what is their alkaline in nature. If you see their nature student here, anyone you see LiOH or NaOH, student. So what they are saying, they are extremely basic. Okay, basic means what student? Alkaline. Okay, alkaline. So alkaline means what student? Alkaline means that is basic in nature. Okay, now we are having that is LiOH, NaOH, KOH, RbOH and CSOH. These are there. Okay, these hydroxide are alkaline in nature, so they are known as alkali metal. Right student? Why they are known as alkali metal? Because their hydroxide are what student? Alkaline in nature. Next one is the group 1 elements are as lithium, sodium, potassium, rubidium, cesium and francium. Now let us look over the electronic configuration student. These elements have valence shell electronic configuration of ns1, that is only one valence electron. For example, lithium, this is there, lithium, sodium, potassium, rubidium, cesium and francium. What you are finding here, that is all is having the only one valence electron student. Since they are having the same number of valence electron, their properties will be the similar students. Now dear student, question is there, why alkali metals are not found in the free state? Because they are highly reactive student, that is why they do not found in the free state. The element with atomic number 87 belongs to S block element students. Now let us move about the atomic and ionic radii. Atomic and ionic radii increases on moving down the group as number of cell also increases. Right student? Atomic and ionic radii increases down the group. Atomic and ionic radii, atomic and ionic radii increases on moving down the group as number of cell also increases. So dear students, see lithium, sodium, potassium, rubidium and cesium. These are there. So if you are moving here, so that is radii is what happening student? Increasing order of atomic radii. If you talk about ionic radii, that is also getting increased student. See 76, 102, 138, 152, 167 and 180. So increasing order of radii. Now let us have a look student, ionization energy. Okay, on moving down the group, ionization energy decreases as the number of cell increases and force of attraction between nucleus and outermost electron decreases, and hence less amount of energy required to remove the outermost electron. So you see student, if you are moving down the group, that is ionization energy is getting decreased. 520, 496, 419, 403, 376 and 375 in kilojoule per mole. Which of the following best describe to alkali metals? They are monoatomic form ions of the general formula X minus. Okay, reactivity. Down the group, reactivity increases as ionization enthalpy decreases. Okay, so hydration enthalpy, it is the energy released when 1 mole of atoms or metal ion dissolve in water. Since on moving down the group, size and ionic size of alkali metals increases, so hydration enthalpy decreases down the group. Element lithium, sodium, potassium, rubidium, cesium. So hydration enthalpy you see student, this much of releasing, this releasing, that is continuously getting decreases, size is getting increased, the hydration enthalpy, what is happening student, getting decreased. Decreasing hydration enthalpy, negative sign means exothermic process. Maximum degree of hydration among the following is what? Lithium. Okay. Melting point. The melting and boiling point of alkali metals are low, indicating weak metallic bonding due to the presence of a single valence electron and larger size. The decreasing order of melting and boiling points are as lithium, sodium, potassium, rubidium. So this is going decreasing order of melting and boiling point. If a decreasing order of lithium, sodium, potassium, melting point, okay, this is, and decreasing order of boiling point, this is there student. Okay, so you can see student, with the value also you can go 354, 371, 336, these are there. Next, which of the following alkali metals is expected to melt if the room temperature rises to 30 degree? Cesium will be melt student, because cesium, okay, melting point you can see student, cesium melting point how much is there? 302. Okay, 302 means what student? 273, okay, plus 25, how much will come student? 892. So 290 is there. If you are increasing 30 degree, it will melt students. Okay, next point is there, flame test. The alkali metal and their salt impart characteristic color to flame. Hence, heat from the flame exits the outer electron to higher energy level, and excited electron come back to the ground state by emission of radiation. So lithium is crimson red, sodium is yellow, potassium is violet, rubidium is red violet, and cesium is blue color. Photoelectric cell or photoelectric effect. The ejection of electron from the surface of metal are known as photoelectric effect. This property makes the cesium and potassium useful as electrodes in the photoelectric cell. Okay, density. Density of alkali metals are low and moving down the group increases, with exception that potassium is less density than sodium. K has a vacant d orbital, so volume is more and and density is less. Okay, so here is lithium, potassium, sodium, rubidium, cesium, increasing order of density. What is the wrong regarding the density of alkali metal? So lithium, sodium, this is the wrong student. Potassium is low density because of high volume. Okay, you can see potassium is has low density. Reaction with air. Reactivity with air down the group increases from lithium to cesium, increasing order of reactivity. Okay, so lithium form, that is Li2O, sodium Na2O, and Na2O2, and other form the superoxide. So they are forming, these are forming, that is monoxide, monoxide, and they are peroxide. Okay, and last one is superoxide, that we have to keep in mind. So lithium form monoxide, sodium form peroxide, while other form superoxide. Solubility and basic strength decreases as go down the group. Solubility and basic solubility and basic strength decreases down the group. Okay, increasing order of basic strength. Okay, what they are saying is the solubility of peroxide and superoxide increases in the order Na2O, K2O, these are so. Now next point is there, among the following metals, which of the following form superoxide? All of these. Which alkali metal nitrates on heating gives NO2? Lithium. All group 1 compound metal nitrates decompose to give metal nitrates and oxygen 2MnO3, 2MnO2 plus O2. Since lithium show diagonal relationship with a magnesium, it show different behavior. So 4LiNO3, Li2O, 4NO2O plus O2. Reactivity with H2O. Reactivity with H2O increases down the group and form the metal hydroxide and metals and releases hydrogen gas 2m plus 2h2o 2MOH plus H2O H2. Reaction with hydrogen. Reactivity of alkali metal with hydrogen increases down the group. So lithium, sodium, potassium, rubidium, whatever they are the with the reactivity with hydrogen is getting increases to. And lithium react with H2 to form covalent hydride. The order of ionic character of alkali metal hydroxide increases down the group. Alkali metal hydride. LiF is less soluble in water than the Kf. LiF has higher lattice energy than Kf, so less soluble. The alkali metal halides that is soluble in pyridine is what is LiCl, because it is covalent, like dissolve like. Considering a greater polarization in LiCl compound to that NaCl, which of the following statement is wrong? Okay, so melting MP of LiCl is lower than NaCl. Okay, LiCl dissolve more, so correct one is LiCl will ionize in water more than the NaCl. So these are the problems are there, students, that we will study in the next video lecture. Thank you so much for watching, friends.